9702 October November 2022 paper 2 variant 1. A steel ball is projected horizontally from the top of a table as shown this, right? So whenever the ball is uh, having a velocity in the horizontal direction, so it's a kind of projectile motion, right? Half projectile motion, right? So initially, we know whenever there is a half projectile motion and body attains the maximum height, so the vertical component of the velocity initially is zero, right? And and it's the case of horizontal projectile motion. The horizontal range will remain horizontal component of the velocity will remain the same throughout the journey, right? So, and the ball reaches to this point, it having a certain time, right? So it's doing like this. So the ball is projected horizontally at a speed of 4.9 meter per second. The ball lands on the ground a horizontal distance of 180 centimeters. So remember, we need to convert this centimeter into meter from the edge of the table. Assuming the air resistance is negligible, calculate the time taken for the ball to reach the ground. So for the horizontal range, we know the formula is velocity is constant. So it's total distance equals velocity times c. We know the velocity if the distance is 18 in 10 to the power minus 2, which is in meter. 4.9 is the speed, so we will get the time, which is 0.367 equals rounding off is 0.37 seconds. Calculate the vertical component of the velocity of the ball as it hits the ground. So first thing first, we need to find we have the formula like 2gh equals v square minus u square, but we need to know what is h. So if when by considering the vertical component of the velocity or the vertical motion, the initial velocity is vertical initial velocity is zero, right? But it has some initial final vertical velocity will be here. So so this is need to find out the vertical component of the velocity as it hits the ground. So we need to find out the vertical component of the final velocity. So half the initial velocity is zero. So we have equation h equals ut plus half gt square. H equals ut plus half gt square. So this is gonna be zero because it is gas. So it becomes only h equals half gt square. So half g is 9.1, 9.81. T we found out is 0.37. So after squaring, we will get 0.67 meters. So putting the value of h over here, 2 into 9.81 into 0.67, we square we need to find, and initial velocity is vertical component of the initial velocity is 0. So it is 0. So we calculated as 3.6 meter per second. Determine the magnitude of the angle of horizontal and the horizontal of the velocity of the ball, horizontal of the velocity of the ball as it is the ground. So angle of the horizontal of the velocity. So there we need to find out the velocity as it at the ground. So we have Vx, which is 4.9 meter per second, which is given, and we have calculated Vy component of final velocity is 3.6. So that velocity means the horizontal after the net velocity, which is combining of the vertical and horizontal component. So the vertical component Vx squared is 4.9 and the Vy is 3.6 to 4.9 square, but 3.6 square we will get 6.08, which is rounding off. After rounding out, it will be 6.1, and the angle tan inverse Vy over Vx 3.6 over 4.9. We have already at the value. So the angle was will be 3.36.3. After rounding off, it will be 36 degrees. So the ball is this part actually we have combination of elasticity. The ball is projected by means of a compressed spring and is attached to a fixed block as shown here. So when it is compressed, so from the original position, which is now the extension x naught, and whenever we have this extension, we have the formula of elasticity, and if it obeys the hook right, right? So it will be F equals Kx. Here it is X naught. So it will be F equals Kx naught. And the energy is half Kx square. Here it is half Kx naught square. The ball is placed on a frictionless track in the front of the spring. The ball is then pulled back so that the spring has a compression X naught. When the spring is released, the ball is projected as shown in this, right? Now, the variation with the comparison X and the force of the spring is this. So we have the table, and remember again, the extension is in centimeters. So we need to consider this as well. So uh, sometimes we may make mistakes by not considering this. So silly mistake, we can see that. The ball is uniform sphere of the steel and the diameter is 0.016 meter and mass is 0.017 kilogram. Calculate the density of the steel. So we know the formula of density equals mass over volume. We know the mass, which is 0.017 kilogram. So the volume, we have the formula is 4 over 3 pi r cube, or we can convert this because we have the diameter. So we will convert this formula from the radius to the diameter. So r is the d over 2. So after simplifying, we will get 1 over 6 pi over d cube, right? D cube. So the density formula is 0.017 over 1 over 6, and pi is 3.142, d is 0.016 cube. After solving it, we will get the density 792.25.63, which is after rounding out, it will be 7,900 kilograms. All the elastic potential energy in the spring is converted into kinetic energy of the ball. The speed of the ball as it leaves the spring is 4.9 meter per second. So the maximum elastic potential energy of the spring is 0.20 joule. We know the formula of kinetic energy, which is half mv square, right? Half mv square, half O2 mass we have, and we know the formula we know the value of speed is 4.9, so it's 4.9 square. So the potential energy, right? Elastic potential energy, which is stored in the string, is 0.204, which is after rounding off, you will get 0.20 joule, which is we need to prove. So, right? So it is true. Now, use figure 2.4, which is the graph determine the spring constant K, right? So we need to go to the graph, we will check. So here is the graph, we need the slope, we know is force upon extension, right? So it will be a spring constant, and it is represented by this gradient. We need to find out the gradient. I took the value of 6 and 2 of the force, and at respective its extension, right? So this was actually 6 minus 2, right? 9.4 minus 3.5. So 0.64 is the value, but you know it's in centimeter, so which is in denominator. So it will go up, become a square. So 0.64 into power 2 will be 64 Newton per meter. Use this answer and of B and the value of energy given this one. B2 to determine the expression. Right. So as it says, all the potential energy is converting into kinetic elastic potential energy, and we found the elastic potential energy is 0.2 half kx, not square, so half. But we got that 64 is the spring constant, and after calculating x naught will be 0.079, because we already need to take the square root, it is x square. So it is 0.079. So after rounding off, it will be 0.08. The steel ball is replaced by the polystyrene ball of the same diameter but much lower mass. The spring is given compression X naught and is then released. Air resistance on the ball is not negligible after it leaves the spring, right? So there are two things we need to consider. The mass is not changed, and the air resistance is we need to consider the air resistance, right? So explain why the ball leaves the spring with a greater speed than that of the speed of the ball. So we had the condition in the speed ball. The speed ball has even they it, before it has we assume that air resistance was negligible in terms of speed. But even if we consider the air resistance there, so even then, the this ball, which is having the less mass, will have the greater speed. Why is it so? Because when the the spring is compressed, right, with the same force, right, the force is the same, elastic potential is the same, right? So if if the elastic potential is the same, so E equals half mv square at its when it is released, right? So energy is the same as previous, right? If the energy is same as previous and the mass is really is now less, so in order to equate, if the mass is less, the velocity should be greater in order to have the same result. The same elastic potential energy due to the same force and same x naught and x naught. So the initial kinetic energy will be the same, but due to the less mass, velocity should increase because of this formula equals half m v square. So same energy, less mass, so this should be get higher to to get the product same energy. Why this ball takes longer time to reach the ground than the steel ball? Due to the air resistance, vertical component of the acceleration decreases, right? So when it decreases, so that means because the net acceleration from the acceleration due to gravity will be less, right? And when it is less, so F equals ma. F is also reduced. The net vertical force reduced, right? To pull the ball downward, so it will take longer time to reach the ground. So just check how much work you got from this out of 17.